just some reviews from last time. When we talk about the probability of some uncertain event, we are basically giving it a number. And the main formula that we use is how many possible outcomes are there and how many favorable outcomes. And that favorable goes back to what is favorable in terms of the event question. And when we are trying to visualize the number of possible outcomes, there are different ways we can do that. One of the ways we looked at last time was a tree diagram where, if we had, let's say, in fact, I think we had one example where we had heads and tails. And then we said, after tossing a coin, you also roll a dice. And we expressed all those options by drawing a tree like this. I know it's not the neatest tree in the world, but you get the idea. So there's actually 12 different ways in which you can throw a coin and roll a dice. There are 12 different options. And if I ask you about something from these choices, it's really helpful to know that there are 12 options. And then if the question is about how many even throws with heads in them, you can then look along your tree to see which of the branches are going to make sense for that question. So that was the one type of way we did it. The other thing we looked at was if we rolled 2 dice, and we talked about using a table. And, if you have 1, 2, 3, 4, 5, 6, those are all the options on dice number 1. But what happens if you have a second dice? Well, then a table is super useful because it allows you to visualize 2 dices happening. And if I look at this table, I know straight away there are 36, different outcomes, although some of them will be the same. So I think we investigated how many different sums are there if you sum up 2 dice, and 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, or 4 plus 1 is 5. So you can really get a good sense of what outcomes are possible for these 2 dice if you use a table. Now today, we are going to focus on another type of thinking tool or diagram. It's called a Venn diagram. But before we get to that, we're going to focus on a little bit of tree first. Okay, give me a thumbs up if what I did in the first bit there sounded familiar to you. Give me a thumbs down if you're like, whoa, whoa, whoa. Hold on, buddy. Welcome to Atlachang and to Silikani, who's also joined us. Silikani. Okay, let's have a look at this question over here. It says there are 12 red roses, 5 yellow roses, and 3 white roses in a vase. Felix takes a rose at random. What is the probability that it is yellow or white? And so this is a useful diagram to just use a simple tree diagram where you say, look, there are red roses, there are yellow roses, and there are white roses. But what I want to ask you is, are all of the outcomes equally likely? So just say yes or no. If you think it's just as likely you get a red as a yellow, say yes. If you don't think these 3 are equally likely, say no. I want to see what you think. Nah, absolutely. You guys aren't falling into that trap because there are 12 red ones, 5 yellow. So there's a lot. If you add these up, how many are there in total? 12 plus 5. There are 20 roses in total. 12 of them are red. You know that the red is the favorite, right? It's clear that it's most likely you're going to get red. So how do we express the probabilities easily and efficiently? You know what we do? We say, look, there's 20 in total, but 12 of them are red. So on this branch, we go 12 out of 20. On this branch, the yellow branch, we write the probability 5 out of 20 because that's how likely it is you get yellow. And then for white, there is a 3 out of 20 chance. So this summarizes all the maths in a nice, neat way. But the question said, what is the probability that you get a yellow one or you get a white one? And that's what I want you to tell me. What do you think the probability is that you draw a yellow or a white one? And then once you tell me the number, maybe choose the option that it goes with in the multiple choice question. Okay, what have we got going on in the chat? Let's have a look. I see Lena has locked in an answer. I love it. Anybody else willing to commit? So first, let's just use our tree diagram. What is a favorable outcome? Well, yellow is a favorable, and so is white. Now, the good news is if two of them are favorable, you can just add them together. 5/20 plus, which is 8 out of 20. But that also makes sense because 5 plus 3 is 8, and there's 20 in total. So this is 8 out of 20, but there's no 8 out of 20. So you have to look for an equivalent fraction. And what's equivalent here? It's going to be 2/5. So B is the correct answer. So on Elena, I agree with you. So that is the example question. Let's see if you can use that idea to help you answer this one. So it says there are 8 colored roses. I'll just cross out that for the moment because these are the 8. 1 yellow, 2 red, 5 blue. What is the probability of picking a blue or a yellow rose? And give your answer in the simplest way possible. So over to you guys and girls. Go and get me my answer. What do we think the answer is going to be? Well, let me start by drawing a tree diagram because so yellow, red, blue. What is in total? I have 8. So that branch is 1 out of 8 chance. That branch is 2 out of 8. That branch is 5 out of 8. And the correct way to do a tree diagram is to write the probabilities on the branches, have the outcomes off the branches at the end. Now, I still need to know what is the probability of getting blue or yellow. Blue is that one, and yellow is that one. We got this right? So I think it's 6 out of 8. But 6 out of 8 is the same as 3 out of 4. And they did say that I must go with the simplest option, so it must be B. All right. Give me a thumbs up if that was all good. Give me a thumbs down if you are feeling uncertain. Just want to get some feedback from the class. Please get those thumbs in the air. Tell me how they... All right. Thank you very much. Okay, well then it is Venn diagram time. So let's do this. So what is a Venn diagram? Well, what a Venn diagram does is it helps us represent different events. Now, an event can have multiple outcomes within it, and this is why Venn diagrams are so useful. So what we do is we have circles and we have rectangles. Now, the rectangle is often represented by the letter S, and it's called the sample space. And it has all of the possible outcomes. Everything that's possible is in the rectangle. Then within S, each circle is a different event. So, for example, event A, let's go with everything that's inside the blue circle is in event A, and everything that is inside the green circle is in event B, and some outcomes are actually in both events. Those are the outcomes that are sitting in what's called the intersection, or in event A and in event B. That's that region over there. The intersection, so the symbol we use to describe that area is A and B, or if we use the word intersection, the intersection is like an unhappy face. So I just think of, I have to do this and I have to do that. Oh my goodness, now I'm unhappy. So that would be the symbol that represents that region there. Now, that sounds a bit abstract, so let's go to an example where it can be made more concrete. So we are given a set A, which consists of those numbers over there. So those numbers have to go into that event A. Then what we have is we have event B, and event B, those numbers have to go in this event over here, the circle over here. Now, the sample space, all possible numbers that are included here are numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Just using your own logic, I want you to draw this Venn diagram and try and fill in the different numbers in the region you think that they go into. So see if you can fill in the numbers in the region you think they should go into. And when you're done filling in those regions, I want you to say done. Okay, so as we look at these two events or two sets, the thing that caught me straight away was 1 is in both, which means 1 must go there. Is 2 in both? No. 3 is in both, so it goes in the intersection. 5, it goes in both. 7 goes in both. All right, so we've handled all those, but what about 2? Well, 2 is only in A, but it's not in B, so 2 must go there. Is there anything else? What about 9? 9 is in B, but not in A, so 9 must go there. So let's cross off all the numbers I've dealt with. 4 hasn't been dealt with. 6 hasn't been dealt with. 7, yes. 8 hasn't been dealt with. 9? Nope. Okay. Where are these numbers going to go? So 4, 6, and 9, where are they going to have to go? Where are they going to have to go? Well, they are going to have to go outside A and outside B. So, oh wait, I lie. 9 has already been taken. So let me correct that. I see something's coming up here. Okay, so 9 was already taken care of. I can see 9 over here. So it's just 4 and 6 that need a home. Is there anything else that needs a home? 2's got a home, so that's taken care of. 4 must go out here, so that's that. Oh, 5. What about 5? No, 5 should be in A. Over there. So I made a mistake there. And what about 8? Where's 8? 8 has to go over here. 1, 2, 3, 4, 8. That's okay. Now I'm feeling happy. Give me a thumbs up if you are with me and your Venn diagram looks the same as mine. Well, this is good news, everyone. Very good news indeed. So, some more set theory probability notation. If I say, what are the number of items in B? What would you say? How many items are in B, in the event B? There are 5, yes, because all of these are in B. And that's what the little n means. Okay, what about how many events are there in, or how many outcomes are there in the event A? Guys, I've just realized I've added something that shouldn't be there. 5 should not be there, it should be here. Now, have I lost something? 1 is there, 2 is outside, 3, 5 is inside, 7 is inside, 9 is outside. Okay, no, that's fine. Yeah, there shouldn't be 2 5s. Well spotted, Simtanda. I'm glad you spotted that. So what do we have here? In A, there is also going to be 5. We got there eventually. Okay, now what about if I say to you, how many items are there in A and B? How many items are there in A and B? So what's little n of A and B? So the only ones that are inside both are that. What about this one? How many items are in A or B? So if you look in here, it can be A or B, or it could, or also means both. So either you're in A or B, or you're in both. So A or B. So 1, 2, 3, 4, 5, 6. Now, the reason some of you are getting caught out here is when we say or, it's basically like how many items are there in this region, and that region there, because it's A or B, or the both of them. So just give me a thumbs up if that makes sense now. And while we're doing the set theory, let's do this one. This is a bit of a strange one, but what if I said to you, how many items are there not in B? So this is saying, look, everything is included except anything in B. How many items are there in B, not in B? So everything that's in B is here. Everything that's not in B is going to be this, this, and this. So the answer is going to be 3. Okay, one more thing that we need to connect. We need to connect probability to this Venn diagram. So if I said you choose one of these random numbers, and I said, what is the probability of getting a number that is in the event A? What would the probability be that you choose a random number inside here? Actually, you know what? Let me go on to the next one for now. I'm actually not going to do that because I've just recognized the 4. Well, actually, no, wait. Let me. The n of, what is the probability of A? Sorry, I was avoiding that too early. How many items in total are there? There are 9. How many items are there in A? I've just realized that there should have been a 6 up here. Okay, so let me, because the numbers go from 1 to 9, but that's fine. You understand the basic idea. There should have been a 6 because we've got all the numbers from 1 to 9 that have to be included, and that's why the 6 went missing there. So 5 out of 9. Okay. Give me a score out of 10 for how you are feeling about Venn diagrams and the basic notation. Pop your score in the chat. Okay. Well then, what I want you to do is I want you to draw me a Venn diagram for this situation here. And you are given the numbers 1 to 10 in the sample space. You are given the event A of the prime numbers. You are given the event B of the even numbers. And you need to draw a Venn diagram with those outcomes placed in the correct circles. So over to you. When you have done your Venn diagram, you are going to say done. And this one, you're going to fly solo. I'm going to get some water while you draw some circles. Now, what I spotted is the only number that's in A and B is 2. So you're going to have a 2 there. But I'll give you a bit more time to finish the rest of your diagram and tell me when you're done. So for me, I get a 3, a 5, and a 7 over there. I get a 4, 6, 8, and 10 over there. But now the question is, can you help me? Is there anything outside? Remember, we have the numbers. Let's cross this off. 2, 4, 6, 8, 10, 3, 5, 7. Here we have 1 and 9, and they are not in A or in B. So if you're not in A or B, you have to be outside. So that's going to be 1 and 9. And just to show you how you would represent that, like A or B is the region over there, not A or B is just that. The dash says, so these guys, 1 and 9, are in that region over there. Okay, use this Venn diagram to help you answer these questions. I will help you with the first bit. So you know that there are 10 possible outcomes because of the set 1 to 10. How many items are there in A? Well, there are 4 items. So if you are randomly choosing a number from the sample space, there is a 4 in 10 chance that you choose a number from the event A. So I did that one for you. Can you do 2, 3, and 4 for me? And then pop your answers in the chat. Pop your answers in the chat. Okay, so B, how many items are there in B? Well, B has 1, 2, 3, 4, 5. So this has to be 5 out of 10 or a half. For this one, it's still going to be out of 10, but what is the probability of being in A and B? The only thing is that 2. So this is a 1 in 10 chance. Yeah. So it's not very likely that you're in both of those. What about A or B? What's that going to be? It seems pretty likely you'd be in either of those two. So if we go out of 10, how many items are in A or B? 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 10 or an 80% chance. Perfect. And just for bonus points, what is the probability that you choose a number that is not in B? What is the probability that you choose a number that is not in B? So everything that is in B is here. So I can't get those items. I'm only counting the 1 and 9 and the 3, 5, and 7. Basically anything that is in the yellow region. So not in B is actually going to be 5 out of 10 items or a half. So not in B is just the yellow stuff. And there's 5 items in the yellow stuff. All right, everyone. I think it is time for a break. So let us stand up and get away from our desks and tables or beds or wherever it is that we are. And we are just going to take 3 nice deep breaths. So let's go like this. Breathe in. Breathe out. Breathe in. Breathe in. One more. Okay, then shake out your arms. Shake out your legs. And okay, then we're good. Now, last thing we're going to do is we're going to do some jumping jacks. And what that is going to mean is this is what a jumping jack looks like. We're going to do 50 of these, and by the end, our hearts are going to be pumping. Okay, 3, 2, 1, let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and there we go. So hit the emoticon that most expresses your feeling right now. Let's do it. Let me know how you are feeling. I am definitely feeling my heart. Boom, boom, boom. That's what it feels like. Oh, I have a little brain puzzle for you, so you can do this before we move on. So you are given 3 numbers, you add them together, and you get the same thing as if you multiply them. What are those numbers? What are those numbers? Atlekang, you are champion for the day. 1 + 2 + 3 is 6. 1 times 2 times 3 is 6. So Atlekang, well done to you. Let's give Atlekang some emoticon applause. Where are the applause? There we go. There we go. There we go. Very well done. Very well done. Okay, let us get back to the task at hand. So here is a Venn diagram setup. I would like you to draw the Venn diagram for me and then tell me when you are done. Draw that Venn diagram and tell me when you are done. Now they do say that there are 23 people who like both types of movies. So the question is about 150 people who are asked what type of movie they like to watch. And so you're going to draw two circles. The question is, do the circles overlap? And they do overlap because some people like both. And the number of people who like both are those people, 23 of them. And let's give this a label A and C. Now, what you have to figure out is what goes in these different regions. Tell me done when you are done. Okay. So if I know that 80 like action, but 23 like both, this region has to be 80 minus 23. And this region over here, with 55 like comedy, this has to be 55 minus 23. Otherwise, you won't get the total that you need. So that has to be 57. And this has to be 32. Now, the question is, how many people don't like action or comedy or both of them? Who knows what that answer is? So it's 150 minus 57 minus 23 minus 32, which is 80, 112, 38. Yes, it's 38. Now, just to connect this, if you randomly choose someone in this group, and what is the probability that they like both action and comedies? What is the probability they like both action and comedies? What's that going to be? What is the number of possible outcomes for your choice? What is the number of favorable outcomes in response to the event question? So it's going to be 23 out of 150. And you can convert that to decimal if you need to. It's easier to compare things when they're decimals, but if you're not comparing, you can just leave it. Okay, one more. What is the probability that someone doesn't like action movies at all? So Note the dash means not in A. So what's the probability that someone doesn't like action movies at all? What's that going to be? So you're not allowed, well, you basically, it's only favorable if you don't choose from this region. So those are not favorable outcomes. The favorable outcomes are the ones that are outside of A, which is basically going to be all of that stuff. So that is going to be out of 150, well, what's 32 plus 38? It is going to be 70. So 70 out of 150. Give me a thumbs up. That was a bit of a tricky one. Give me a thumbs up if you understood that. Give me a thumbs down if you didn't. Let me see those thumbs. Thumbs up if you understood what I was doing. Thumbs down if I lost you. Okay, fantastic. So what we have now is some Venn diagram choice questions. So let's do these. What do you think is the correct answer for this question, this multiple choice question? Go ahead and tell me what you think. Simtanda has locked in an answer. Let's see other people commit. Put your money where your mouth is here. So studying Spanish, well, there's 150 in total, but Spanish language speakers are this circle, which is 53 out of 150, which is C. Fantastic. Let's go on to, should we do this one? Can you answer this question? So there's 120 language students. How many of them choose to do French? It is going to be, well, what's the French? That's this one. So it is going to be 55 out of 120. So is there one that's 55 out of 120? Option D is correct. Yeah. Okay, I think it's time for me to spice it up a little bit. So let's leave those for now. Leave that for now. Leave that. That's fine. We can come back. Okay. Here is a question that I want you to have a go at. So, in a class of 25 students, each student plays hockey, football, or both. 18 students play hockey, 15 play both football and hockey. Try and draw a Venn diagram for that, and then see if you can answer these questions here. See if you can answer these questions here. Okay, let's have a look. Each student plays hockey, football, or both. So what that's actually saying, so let's have hockey and then football. And it says every single student is inside these two circles. So there's actually nobody outside these circles. It says 15 play both of these, which then means if 18 play hockey, that must be 3. And since in total all 25 go in there, this has to be 7. How many students play football? 20. Ugh. How many students play? Is this wrong? Let's have a look. Each 18 students play hockey. 15 students play both football and hockey. Oh, this question is wrong. So 25. Have we got 25 students? Yes, we do. Yeah, so everybody, this has to add to 25. Okay, this question is wrong. So we're going to move on. Give me a thumbs up if you understand why none of these options can be correct. If it said play only football, if it said play only football, then there would be a correct answer. And the only plays football would be 7. But you have to say only because there are 22 students who play football. Okay, fine. That's good. We're on the same thing here. Let's do this one. Maybe this one will be better. In a class, there are 11. Let's see if you can do this. Draw the Venn diagram and see if you can figure out how many students there are in this class. So we have French, German. There are 11 who study French and German. So that has to be in the intersection. There are 5 who do not study a foreign language. Then 14 students study French, and 11 are already there, so that has to be 3. 24. Hi, everyone. Sorry, I don't know what happened there. I seem to have lost the feed for a second. Can you hear me okay? Just give me a happy smiley face if you can hear me and I'm back. Okay, fantastic. So what do we think is the answer to this question? So it's just going to be 3 plus 11 plus 13 plus 5. Is there an option there? 14, 27, 32? It's going to be that one, which is C. So that's that there. Okay, let's keep swimming. Let's try and do this one. I'll give you a minute. Just say done when you've drawn the diagram and see if you can do it. So we've got our cricket players. Then we've got, what have you got? Cricket. And then we've got football. And we know that there are 25 students in total, but 8 students don't play any sport. So if there must be 8 out here, and in total there's 25. So 25 minus 8, this region inside here, this yellow region has to have 17 people in it. Give me a thumbs up if you understand that this yellow region has to have 17 people in it. Just let me know, because it's going to be important for the next bit. Thumbs up if you understand why the yellow must be 17. Okay, now it says 9 students play cricket. So that's the blue circle. 11 students play football. But we don't know how many people play both. So you know what we're going to do? We're going to make this X. If this is X, and we know that there are 9 students who play cricket, that must be 9 minus X. And football, 11 play football, but then this must be 11 minus X. Again, give me a thumbs up if you understand. I had to have a placeholder for the middle here. Do you understand how I got the numbers that go in the yellow bits? Thumbs up if you get it, thumbs down if you don't. Now, what I was saying earlier, awesome, thanks. So 9x plus x plus 11 minus x must be equal to 17, because 17 was how much had to go in the yellow region. And if we then solve this equation, we've got 18 minus x. Wait, not 18, it's going to be 20. So it's going to be 20 minus x equals 17, which then is going to mean x is equal to 3. So how many students play both cricket and football? What's the answer? A, B, C, D. The answer must be C. All right, we're almost done for tonight. I just want to show you one other type of question. Not this one. I just want to talk about when we color in Venn diagrams. So this question says, what set notation is represented on the following diagram? And I would say that this is, the gray region is the region A and B. But sometimes, instead of using and, we use the intersection symbol, which is the unhappy face. And so the correct symbol for that would be that one over there. So this is just when we're describing sets from set diagrams. If I go and look at this one, let's not do that one actually, let's do this one. This is, the shaded region is in the region A or B. But instead of using or, we sometimes use the happy face for the union of two sets. And so the correct answer would be here. And that's just some language for probability and set theory. Give me a thumbs up if you're with me so far. Thumbs up if you're good. Thumbs down otherwise. Okay, that's good. Now, what about this one over here? This is saying everything not in B. So everything that's not in B is basically going to be everything outside of this. Which of the options A, B, C, or D do you think is the correct answer to describe the yellow area that I'm squiggling on here? Which of the 4 options do you think is correct? Well, it has to be this one. It's everything not in B. So it's B dash. What about this? That for me is the region is shaded is A and B and C. It's all those things that are in A and B and C. Which of these four options do you think is correct? Is it this one? Is it A? Is it B? Is it C? Or is it D? Indeed, it's just going to be that one, B. Okay, let's see if I can find one more and then we are done. How would you describe what represents that shaded region? Okay, so I think we all know that that is just A, and so the correct answer is going to be A over there. All right, everyone. That is tonight's lesson. It's our first lesson on Venn diagrams. In the next lesson, I will be dealing with formal identities, and I'll also be dealing with when we have three intersecting events. So that's where we're going to in the next lesson.